India made successful landing on Moon. The whole world celebrated this success. But did you know that during the Pragyan rover's mission, it found oxygen and sulfur on the Moon? This discovery is really very interesting. On the 23rd of August 2023 was the day when Chandrayaan-3 landed successfully. The next day, on the 24th of August, Vikram lander took the Pragyan rover down a ramp to start its mission. From the 24th of August to the 4th of September, Vikram and Pragyan made observations on the Moon for around 12 days. On the 28th of August, LIBS laser-induced breakdown spectroscopy instrument confirmed the presence of sulfur on the south pole of the Moon. This was the first time that this was confirmed on the ground on the south pole of the Moon. That's why it is called the first ever in situ measurement. This LIBS instrument has been developed with ISRO by Bangalore's Laboratory for Electro-Optics Systems. Its job is to analyze the composition of the soil and rocks on the Moon. And the way it works is also very interesting. It uses high-energy laser pulses. A laser is focused on the soil of the Moon, whose temperature is very high. This laser is targeted at a small area of the soil on the Moon. The soil there, due to this high temperature, gets converted into plasma. Here is the question: what is plasma? The four states of matter: solid, liquid, gas, and the state after gas is plasma. When you put gas through extremely high temperatures, it gets converted into plasma and the plasma emits light. The special thing about this light that is emitted is that different elements produce different wavelengths of light. And LIBS instrument here measures the different wavelengths of light, and based on that, it can identify the elements present in the soil of the Moon. This is where the name comes from, laser-induced breakdown. It used a laser to break down the stones or soil particles. It converted them into plasma and then measured the wavelength emitted by them through spectroscopy. This is why it is called laser-induced breakdown spectroscopy. NASA's project scientist Noah Petro says that the Apollo and Lunar missions of Russia and America had detected the presence of sulfur on the Moon in the 1970s. However, the discovery made by Chandrayaan is a tremendous accomplishment. Because these are in situ findings. It is the first experiment on the ground. The technology used before this was not so accurate. For example, in 2011 NASA found that there's a large quantity of titanium on the Moon. But they used their Lunar Reconnaissance Orbiter for this. An orbiter spacecraft that is orbiting or revolving around the Moon. The evidence wasn't found by landing an instrument on the Moon. Similarly, in 2009 a Japanese spacecraft also detected uranium on the Moon. However, the technology used in LIBS is much more advanced. And this is the first time that we made a definite discovery of sulfur. Apart from sulfur, elements like manganese, silicon, and oxygen have also been confirmed. You might be astonished at oxygen being present on the Moon. More than 40% of the lunar crust is composed of oxygen. This oxygen is actually present in the soil and rocks of the Moon. This oxygen is not present in the atmosphere in the form of O2 gas, because there is no atmosphere on the Moon. In fact, in the rocks of the Moon, oxygen atoms exist in the form of bonds with different elements. For example, silicate minerals are formed from silicon and oxygen atoms. This is exciting news because this oxygen can be extracted and used for other use cases. For example, if there happens to be a permanent base on the Moon for astronauts and oxygen is required there, then oxygen can be extracted from the rocks of the Moon. In the article from the 25th of April of this year, NASA successfully extracts oxygen from lunar soil simulant. It means that NASA has already worked on the technology of extracting this oxygen. The quantity of oxygen is so high in the Moon's soil that it is said that the oxygen in the topsoil of the Moon is enough to sustain 8 billion people for 100,000 years.